In astronomy, magnitude is the logarithmic measure of the brightness of an object, measured in a specific wavelength, a passband, usually in the visible or near-infrared spectrum. An imprecise but systematic determination of the magnitude of objects was introduced in ancient times by Hipparchus. Astronomers use two different definitions of magnitude: apparent magnitude and absolute magnitude. The apparent magnitude is the brightness of an object as it appears in the night sky from Earth, while the absolute magnitude describes the intrinsic brightness of an object as it would appear if it were placed at a certain distance from Earth. This distance is 10 parsecs for stars and 1 astronomical unit for asteroids and planets. The size of an asteroid is typically estimated based on its absolute magnitude. The brighter an object appears, the lower the value of its magnitude, with the brightest objects reaching negative values. The Sun has an apparent magnitude of -27, the full moon -13, the brightest planet Venus measures -5, and Sirius, the brightest visible star in the night sky, is at -1.5. An apparent magnitude can also be assigned to man-made objects in Earth orbit. The brightest satellite flares are ranked at -9, and the International Space Station appears at a magnitude of -6. Since the scale is logarithmic, each step of one magnitude changes the brightness by a factor of about 2.512. A magnitude 1 star is exactly 100 times brighter than a magnitude 6 star, as the difference of 5 magnitude steps corresponds to 5 or 100. Scale is mentioned above. The scale appears to work in reverse, with objects with a negative magnitude being brighter than those with a positive magnitude. The larger the negative value, the brighter. Objects appearing farther to the left on this line are brighter, while objects appearing farther to the right are dimmer. Thus 0 appears in the middle, with the brightest objects on the far left, and the dimmest objects on the far right. Problems. The human eye is easily fooled, and Hipparchus's scale has had problems. For example, the human eye is more sensitive to yellow-red light than to blue, and photographic film more to blue than to yellow-red, giving different values of visual magnitude and photographic magnitude. Apparent magnitude can also be affected by factors such as dust in the atmosphere, a light cloud cover absorbing some of the light. Furthermore, many people find it counterintuitive that a high magnitude star is dimmer than a low magnitude star.